Okay, now we're going to be looking at objective functions. So what is an objective function? It's a function that has two variables. Usually you'll see it as x and y, and it is written as z equals capital A times x plus capital B times y, where A and B are just numbers, and they're not going to be zero. So objective functions will maximize. Sometimes it'll be asked to minimize, but more often than not, they'll be asked to maximize a system of inequalities. So, for example, maximize this objective function subject to these conditions. Well, the first thing you would have to do is to graph this solution. We already did that in a previous video. So we did that in a previous video, and that was our solution. And we have to get the vertices, okay? So we've got the vertices. And we want to maximize this. Let's see if I can get it in the same frame. Okay, so it's always presented as z equals, but what I like to do is to get rid of that z and write it. It's a function of both x and y. Because now I'm going to start to go down the list of vertices. Start anywhere you want and then go counterclockwise or clockwise. It doesn't matter. So I'm going to start here at 0, 2. So 0, 2. So x is 0 and y is 2. So this will give me 6. And then I go up to the next one. So I'm going clockwise. And so this is my general formula. What will that be? I'll have 2 times the x coordinate plus 3 times the y coordinate. So that's 24. Then continuing, I have 2, 6. So what will that function be? 2 times the x coordinate plus 3 times the y coordinate. So that's 4 plus 3 times 6 is going to be 18, and that'll give me 22. Then continuing, I come to 5, 0. So I'm going to have 2 times the x coordinate plus 3 times the y coordinate. That'll give me 10. And then lastly, for this guy, I've got 2, 0, and according to this formula up here, it's going to be 2 times the x coordinate plus 3 times the y coordinate. Now, which is the maximum? That is my max. So, what is the maximum? The maximum is 24, okay? And where do I find the maximum? At the vertex 0, 8. Okay. Now, what they'll do on the final is you'll be asked, here's the objective function, what's the maximum? One of the selections will be 24, and then you'll have another selection that says 25, another selection that says 26. And if you have no idea how to do an objective function, you're just going to be guessing. So let's do one more where they don't give us the horrible conditions first, they just give us the picture. So let's see if I can move this in here. Okay, so we've had this before. And let's maximize the objective function. Z equals 2x plus 3y. Okay. And again, it's the same thing. I need to get what the vertices are. So I'll start here. So I like to rewrite it in this form. And so what are my vertices? I've got 4, 0. So that's going to be 2 times 4, which is 8, plus 3 times 0. Then what's the next one? 0, 3. And according to this formula, that's going to be 2 times 0 plus 3 times 3. So that'll be 9. And what's the next one? 0, 6. And that'll be 2 times 0 plus 3 times 6. Then what's the next one? 5 comma 6. It'll be 2 times 5, which is 10, plus 3 times 6, which is 18. So that'll be 28. And then I've got 5 comma 2. And that'll be 2 times 5 plus 3 times 2. 10 plus 6 is 16. So what is my max? My max is 28. And the vertex at 5 comma 6 maximizes my objective function. Okay, so that should be enough for you to do these objective function questions.